Good afternoon. This is Kirt Cathey with 5 Hacking Tips. Thanks for joining us this afternoon. Today I wanted to cover Windows exploit development and basically what we would call egg hunting. Egg hunting is a little different than, egg hunting per se is actually just it's a reference to the way that this particular exploit is developed, and it's a little more complex than like a regular buffer overflow or a heap overflow where you just gain EIP. There's a bit of a lookup routine and that kind of. So I'll get into that. The other thing though is a thing that came up, and it came up in the cybersecurity chat, one of the chats over the week, and it comes up quite regularly, but I just wanted to address it here. And a lot of people ask, especially when they're starting out, there's exploit development and then there's malware development, and both are very red team kind of things. But I would say that exploit development's a little more on the research side, where malware development's very much expressed. Malware, it's something that you're going to use. It's another piece of software that you're going to use to attack something. So that's malware. It would generally most likely be another piece of software, but not necessarily. It could also be a library. Versus exploit development, when you're looking at exploit development, you're looking at an existing piece of software, either a DLL or EXE, and you're fuzzing it, and you're looking for a way to inject some code into that already running software, or for example, server software, if it's already running, and you do a proper heap overflow, or like I'm going to explain today, an egg routine injection into it, you can successfully gain access to the system while it's running in the privileges that server, that service is running on. Another thing is, though, is you can actually take the executable, create basically a poison or an executable, the exact same executable with a backdoor routine in it, and then like the next time that it's run or it's booted up, you can actually take advantage of that backdoor that you've already embedded in as an exploit into a piece of software. So here, let me change my screen, and today this is the material that I created. So it's basically a technique that we call egg hunting. So the very basic thing when you start studying exploits, either in Linux or Windows, it doesn't matter. They're both pretty much the same. In x86 per se, what you're looking at is a heap overflow condition where you send in a large payload and it overflows a buffer or a variable that intakes the information, and it overwrites this EIP area, and then it probably flows down below that and then create the stop condition. And you don't want to stop the condition, you want to be able to inject your own code. So this red area indicates like a regular buffer overflow would consume all of this area. And if you understand how to do buffer overflows, I'm not going to cover it this time. That's a bit basic, but I may come back to it. Basically, what you're trying to do in a regular buffer overflow is overwrite this EIP, executable index pointer register, and that sets the rest of the payload to executable. So you can add a payload here and execute the rest of this payload. With egg hunting, you're basically in a situation the way that it's depicted here. So some of you who are familiar with buffer overflows are looking at this diagram saying, what? So in a regular buffer overflow, your EIP overwrite would be way up here, and you'd have a lot of extra payload down below most of the time. But when you find that you don't, and you actually get a heap condition, and you find that the payload part that is overwritten after EIP, within that you don't have that many characters. Or if you see obfuscation, if you're going like A's, B's, and C's, and you see obfuscation in the C area that you're injecting, you can say, well, then you don't have enough information. So say we have 100 bytes here. That wouldn't be enough to get a backdoor payload, something to command and control from. So we use what we call an egg technique. And what this egg technique is basically we create an egg routine, is what they call it. And you can create one in Mona. I've got it written over here, the command. I'm assuming tools are immunity debugger 1.8.5, I think. But anyways, when you create an egg, you're basically creating a machine routine that looks at all of the memory that's on the stack and looks for a keyword. And in this case, I wrote root, R00T. That's a tag that we assign to this routine when we create it. So I'm creating that particular routine here that goes through the whole memory stack and looks for this keyword. And actually, it only executes the code after the keyword when it sees the keyword twice. So that's why up here in the code, it's written twice. I'll get back to that in a second. But anyways, that's the concept. So an egg is typically, I think it's 20 bytes or 30 bytes, 40 bytes. So it will fit within this, no problem. And you also, within the EIP, you have to go back and you have to get like a jump ESP command. And the way to do that within Immunity is type this command and it'll show a bunch of addresses where jump ESP command, the jump ESP command is available. And you reference that in the EIP, and that sets this egg as executable right after that. And the egg will actually look through the whole stack. So you can prepend your payload with the actual payload. In a regular buffer overflow, this is just overflow material. We override EIP and we execute our payload down here. With an egg, there's a couple of options. For example, if you don't have room up here either, but you could squeeze the whole thing into memory with like a separate connection into the same server. So with this concept, there's a couple of other strategies by using this technique. So just remember that egg is basically a small script that you create. It's an assembler script, as it comes out as hex. It's an assembler script that you put in to the code, and then because of that, it looks back through the memory stack and it looks for this keyword or this tag or marker, and it executes there. So for example, if we look at this payload that's created with this Python code up here, sorry, it's coming up really small. Can you see I hope you can see my cursor. It's really small here for me anyways. I hope you're watching this on a bigger screen. But we have some very basic Python payload creation code. I'm not going into the injection, how to connect to the server. Now that's all Google or Stack Exchange. But anyways, this is the egg hunter code. And this is what we've generated by running this Mona command in Immunity Debugger. And you can see along here, if you look really close, there's this XB8 and then woot, right? I changed it down here to root. This should actually say root, but it says woot. But that's the key word that this egg hunter that you generated from here is going to look for. This should be a W, but whatever. Or this should be an R up here, actually. But anyways, that's the egg hunter code. You're going to find that the egg hunter code that you generate from Immunity is reusable. So that's another thing to put up in your notes or your cherry, whatever electronic notes you use when you hack. And then this is an MSF Venom payload. These were like the bad characters found. And this is the shell code. All right. So what we have to do to make this egg scheme work is, if we look at egg hunter, we're basically taking this egg hunter and we're putting it in. We're taking that and we're adding that to the C area down here. So if we look at the payload, we get to the root of it. At the beginning of the payload, we have our shell code, which is this variable right here with our 2 times. You have to make sure that you have the keyword that you're looking for, or you want the egg hunter to look for in the stack 2 times, plus the shellcode. It's got to be pre-pended. In other words, it's got to be at the beginning of the shellcode. Because anything right after the second instance of the keyword or the tag or the marker, whatever you want to call it, is executable, and it will execute this shellcode. In this case, it just runs calc. So let's look at this payload again. So that's the shellcode part. And then it basically goes ahead and adds the A's after that to get up to EIP here, if there are any left after the shellcode, and there should be. And then after that, this is our identified JMP ESP address. And then I forgot to put a marker here, but this is Indian actually. So the address is 77E2EE83. This is written backwards because the way the system's going to read it or understand it. And then after that, we have the egg hunter that goes in. And a lot of people ask this, that this is really confusing when you're building a payload, is why does that go in? Well, what comes at the end of the payload is what goes in first. So that's why that comes at the end of toward the end of this variable. And then that's also padded with, the 100 C's that we had there before. Well, there goes my wife, or there goes my printer. I think it's my probably printer. Please excuse that. We all live somewhere. Anyways, thank you for the time. I hope, this clarified. Egg hunting is confusing in the very beginning, especially, once you get heap overflows behind you, because a lot of people start out with this. They don't come from a really strong programming background. It's hard to understand. So I hope I help. If you don't understand, please comment, please share, and please like and subscribe if you can. Every little bit helps. Had a little overlap there. Also, if you're asking about the hat and the black eye, it's not what you think. The hat's actually covering up a pretty big scar or a wound that I had. I slipped on some rocks while doing some mountain climbing. Hit my glasses. Bad scene. Anyways, talk to you later. Thanks for joining, and send any questions if you have any. Appreciate it. Thank you.